Okay. Let's talk about determining equilibrium constants for aqueous reactions. So, simplest way is to look them up. Right? So, if you need the Ka of something, you should be able to find a table of Ka somewhere. There's one in your at the back of your book. Okay, there's plenty of websites where you can find these KB, KSP, and KF. Okay, so and their handbooks. Lang's handbook is a very good source. Lang's handbook of chemistry and of chemistry. Okay, and it's a very good source of data for chemistry and um, it's kind of expensive, but they sell a lot of these used on Amazon. It's really cheap. So I got a few for the lab last year. Uh, there's also the CRC Handbook of Chemistry and Physics. So for a lot of these things that we look up in this class, those are really good handbooks to have. So if you're going to be doing a lot of chemistry, that's a good thing to have. Okay, you don't need a new one; just buy a used one. There's a lot of cheap used ones you can buy. Okay, so that's one way. That's the most straightforward way. The second one is just to do the experiment, okay, and you measure your activities at equilibrium, okay. Now, one thing you'll find when you do this in the lab is, remember we said when we use concentrations and partial pressures as activities, we are in a way just approximating. So there's a lot of finer details that we're not going into at this level. So chances are when you do this in the lab, in the freshman lab at least, your data is not going to be, you know, you're not going to get very good agreement with the results you're getting compared to the literature values that you find in the handbooks, okay? And that's partly because we're making approximations when we use molarities for activities. Now, our third method is you can combine reactions with known KEQs, just like you did with Hess's law when you figured out delta H. You can do the same thing with this one. We talked about this already, except that you don't take the negative and you don't add or subtract. What happens if you flip a reaction? The equilibrium constant is just the reciprocal instead of the negative, right? And if you add two reactions, the resulting equilibrium constant is the product of the two original equilibrium constants. Another method is you can calculate it from the standard Gibbs energy of reaction. We talked about this already when we did the second and third law of thermodynamics. Okay, delta G naught, you can look that up from tables. From Actually, you can calculate that from the table of delta G formation values, right? Or you can say that that's delta H reaction, uh, delta H of reaction minus T delta S of reaction, okay? And from that, you can calculate your KEQ. Okay, so KEQ will just be e to the negative delta G naught over RT. For redox reactions, we talked about this too when we had electrochemistry. And delta G, okay, is just negative N times the Faraday constant times the standard cell potential, delta G naught. And so if you know delta G naught, you can calculate KEQ. All right, so we're going to focus on, we're going to look at, see some examples of these, okay?